Okay, today we're going to talk about how Rolle's theorem and mean value theorem works and what they actually are. First off, let's look at Rolle's theorem, which is that f be continuous on the closed interval a to b and differentiable on the open interval a to b. If fa is equal to fb, then there is at least one number c in ab such that the derivative of fc is equal to 0. And moving on to the next slide, we can see how Rolle's theorem is applied graphically. We can see that on the closed interval a to b, there exists one point c whose derivative is exactly equal to 0. And now, next, I will provide you guys an example to see how Rolle's theorem works, which is to see how this theorem applies to the function fx is equal to x squared minus 3x plus 2 on the interval 1 to 2. Find the value of c guaranteed by the Rolle's theorem. According to the Rolle's theorem, there exists one point whose derivative is equal to 0. So first, let's take the derivative of this function, which is equal to 2x minus 3. And as we know from the theorem, the derivative of this point is equal to 0. So we can get an equation that 2x minus 3 is 0. And by solving this equation, we can know that x is equal to c is equal to 3.2. And then we just successfully find the point, which is 3.2. And moving to the next theorem that we are going to talk about today, which is the mean value theorem. It is, if f is continuous on the closed interval a to b and differentiable on the open interval a to b, then there exists a number c in a to b such that the derivative of c is equal to fb minus fa over b minus a. And on this slide, we can see how this theorem works. From the graph, we can know that there exists at least one point in the interval a to b where the slope of the tangent line is equal to the slope of the secant line drawn between the two endpoints. This also means that there exists at least one point where the instantaneous slope is equal to the average slope on the interval. And now we know how the mean value theorem works. Let's move on to the first example about it. Suppose that we know that fx is continuous and differentiable on the interval 6 to 15. We also know that f6 is equal to negative 2, and the derivative of fx is smaller than or equal to 10 for the interval. What is the largest possible value for f15? So according to the mean value theorem, there exists one point whose derivative is equal to f15 minus f6 over 15 minus 6. And according to the question given, we can know that this value is smaller than or equal to 10. By simplifying this equation, we can know that f15 plus 2 over 9 is smaller than or equal to 10. By multiplying 9 on each side, we can get f15 plus 2 is smaller than or equal to 19. And then we subtract 2 on each side and get f15 is smaller than or equal to 88. Since the question let us find the largest possible value, so we just get the answer 88 for the question. And moving on to the next slide. The example 2 is that to determine all the possible numbers c which satisfy the conclusion of the mean value theorem for fx is equal to x cubed plus 2x squared minus x on the interval negative 1 to 2. For this question, to use the mean value theorem to find the answers, there are two things that we need to find. The first one is the derivative of the function, and the second thing is the value of f2 and f negative 1. First, we can know that the derivative of the function is equal to 3x squared plus 4x minus 1, and the value of f2 is equal to 14, and the value of f negative 1 is equal to 2. By plugging the value of f2 and f negative 1 into the mean value theorem, we can know that f2 minus f negative 1 over 2 plus 1 is equal to 4. And then using the value 4 and the derivative of the function that we just get, we can get the equation that 3x squared plus 4x minus 1 is equal to 4. By solving this equation, we can know two x values that satisfy this question. The first x value is x is equal to 0.786, and the second x value is equal to negative 2.12. Moving on to the third example for the mean value theorem. Ben rides a unicycle back and forth along a straight east-west track. The twice differentiable function b models Ben's position on the track. The table below gives values for bt and Ben's velocity vt. For the interval from 40 to 60, must there be a time t when Ben's velocity is 2 meters per second? Justify your answer. And looking into this table, we can find that vt, which represents the velocity, is actually the derivative of bt, which represents the position of Ben. This means that we can use the mean value theorem to find out whether Ben's velocity is 2 meters per second in this interval. By plugging those values, b60 minus b40 over 60 minus 40 is equal to 49 minus 9 over 20, we can find the answer is 2. So as indicated by the mean value theorem, there is a slope on the interval from 40 to 60 for the function bt, which is equal to 2. And this justifies the statement that there is a time when Ben's velocity is 2 meters per second. And now let's look into the first homework question there. The functions f and g are differentiable for all real numbers, and g is strictly increasing. The table above gives values for the functions and their first derivatives as selected values of x. The function h is given by hx is equal to fgx minus 6. And the question A is that explain why there must be a value r for the interval 1 to 3 such that hr is equal to negative 5. And the question B is that to explain why there must be a value c for c is bigger than 1 and smaller than 3 such that the derivative of fc is negative 5. So firstly, for the first question, we need to first find the value of h3 and h1. By plugging in those values from the table, we can find that the value of hc is equal to negative 7 and the value of h1 is equal to 3. So since hx is differentiable and therefore continuous on the interval, because negative 5 is larger than h3 and smaller than h1, the intermediate value theorem guarantees that there is a value that hr is equal to negative 5 on the interval. And now let's move to the question B for the question 1. In this question, we need to use the mean value theorem, h3 minus h1 over 3 minus 1, because we need to find out if there is a value that the derivative of the function hx is equal to negative 5. And by plugging those values, we can find that the final answer is negative 5, which means that the mean value theorem guarantees there is a value c such that the derivative of hc is equal to negative 5 on the interval, because hc is both differentiable and continuous. Now we have finished the question 1 and we are moving to the next question. Let f be a function that is differentiable on the open interval from 1 to 10. If f2 is equal to negative 5, f5 is equal to 5, and f9 is equal to negative 5, which of the following must be true? First, f has at least 2 zeros. Second, the graph of f has at least one horizontal tangent. Third, for some c, 2 is smaller than c and c is smaller than 5, and fc is equal to 3. Since it is calculator allowed, we can just have a graph here. And from the graph, we can know that f has at least 2 zeros because the sign of the functions has changed 2 times on the interval from 1 to 10. And also, the graph of f has at least one horizontal tangent there, because the function first increases and then decreases, which means that there must be a sign change in the slope of this function. And also, it is sure that for some c from 2 2 is smaller than c and c is smaller than 5, that fc is equal to 3. Because we know that f2 is equal to negative 5 and f5 is equal to 5, and 3 is a number between them. Since this function is continuous, there must be a such value c. And then the final answer is just e. And now let's look into the third homework question. The function f is continuous for the interval from x is greater than or equal to negative 2 and smaller than or equal to 1, and differentiable for x is greater than negative 2 and smaller than 1. If f negative 2 is equal to negative 5 and f1 is equal to 4, which of the following statements could be false? For the choice A, there exists c where c is greater than negative 2 and smaller than 1, such that fc equals to 0 must be true because it is a value between negative 5 and 4. So since this function is continuous, there must be such a value. And the thing is actually the same for the choice C, which states that there should be a value for fc is equal to 3. 3 is also a value between negative 5 and 4, so this statement is also true. And for the choice B, there exists c where c is greater than negative 2 and smaller than 1, such that the derivative of fc is 0. This statement could be false and could be true because we can only know that this function increases on the interval from negative 2 to 1. But we do not know if this function firstly increases and then decreases, or just constantly increases its value. If the function is just constantly increasing, this statement must be false because no slope there can be 0. And then moving on to the fourth question. If f is continuous for the interval x is greater than or equal to a and smaller than or equal to b, and differentiable on the interval for x is greater than a and smaller than b, which of the following could be false? For the choice A, the derivative of fc is equal to fb minus fa over b minus a for some c such that c is greater than a and smaller than b. This statement must be true because that's just what the mean value theorem states. And for the choice B, the derivative of fc is equal to 0 for some c such that c is greater than a and smaller than b. This statement could be false because on a continuous and differentiable interval, the function can be constantly increasing or just constantly decreasing without having to change its size for its slope. And for both choice C and D, they must be true because according to the extreme value theorem, there must be a maximum and minimum value for a continuous function on the interval x is greater than or equal to a and x is equal to or smaller than b. And now let's look at the fifth homework question. The value of c guaranteed to exist by the mean value theorem for Vx is equal to x squared on the interval from 0 to 3 is a1, b2, c 3 over 2, d 1 over 2, e none of this. The solution is just to apply the mean value theorem there and just plug in the values. v3 minus v0 over 3 minus 0 is equal to 3. And the derivative of the function is 2x. So we have an equation right now which is 2x equals to 3. And then by solving this equation, we can know that the x value for the answer of the question is 3 over 2. So we just pick the choice C. Now we are moving on to the homework question 6. If px is continuous in the closed interval k to m and differentiable in the open interval k to m, then the mean value theorem states that there is a point between k and m such that, and there are 5 choices, and what we have to do with the problem is just to write out the mean value theorem formula for this, which is pm minus pk over m minus k equals to the derivative of pa. And we can see that in choice B, it just multiplies k minus m on both sides, and So we choose place B for this question. And now we move on to the homework question 7. The mean value theorem does not apply to fx equals to the absolute value of x minus 3 on the closed interval from 1 to 2 because a. fx is not continuous on the closed interval from 1 to 4. b. The fx is not differentiable on the open interval from 1 to 4. c. f1 is not equal to f4. d. f1 is greater than f4. And the answer to this question is B, because mean value theorem cannot be applied when the function is not differentiable. And for this absolute value function, the point is definitely not differentiable on x equals to 3 because there is a sharp turn. And now moving on to the next slide, we will see homework question A there. Train A runs back and forth on an east-west section of a railroad track. Train A's velocity, measured in meters per minute, is given by a differentiable function VAT, where time t is measured in minutes. Selected values for VAT are given in the table above. A. Find the average acceleration of train A over the interval from t is greater than or equal to 2 and smaller than or equal to 8. B. Do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time t with t is greater than 5 and smaller than 8? Give a reason for your answer. And now let's first look at the solution for the first question. It asks us to give the average accelerations over the interval. So we just apply the mean value theorem here, which is to do the following calculations. V8 minus V2 over 8 minus 2 is equal to negative 120 minus 100 over 6 is equal to negative 220 over 6, which is equal to negative 110 over 3 meters per minute square. And now moving to the second part of this function. Since VAT is differentiable and therefore continuous on the interval from t is greater than 5 and smaller than 8, because negative 100, which is mentioned in the question, is greater than negative 120 and smaller than 40. The intermediate value theorem guarantees us that VAT is equal to negative 100 at some point in the interval. As we can see that from VAT5 to VAT12, the function increases, and because it is continuous, it is impossible for the function to not have a point. To not have a point with VAT is equal to negative 100 in this interval. And finally, these are all the questions and the definitions of the mean value theorem and the Rolle's theorem. Thanks for listening to today's lesson.